Hi, welcome to the review of the 3D printer output. Last time we had made this part and we made it on low quality. And low quality on the Dremel printer is defined as a resolution or a granularity, I don't know what the proper term of 0.3 millimeters. Okay, this works out to 0.012 inches, which is 12 mils. The high quality, and that's what this one is, I added some extra notches to check other things out, is rated at 0.1 millimeter, that's millimeter, which is 0.3 inches, which is 3 mils. They have an intermediate one, and they also have an ultra-high version, and the ultra-high version is able to get down to 1.5 mils. I didn't try that out. Now, the difference in time is this part here on low quality took 1.5 hours. This guy took 4.25 hours. Higher quality. Now, I don't know if it ended up in time because I added all these extra notches. So to explain what these parts are, oh, and here's where I tried to print a test piece inside the other, but it got fused in. It was supposed to be a part that I could pull out, but it evidently got heated and smushed together, so it doesn't come out. And also on this one, I got rid of the through holes through the things because I didn't need them for this. So what we have on each one of these, okay, let me set this up right, is we have 4 holes. I told the 3D printer that I wanted this hole to be 0.75 inches exactly. This one would be 0.752, 0.754, 0.756, 0.758, and 0.760, 0.74, I believe it was 8, and 0.746. The purpose of all this is to find out how good the 3D printer can get there. And one of the reasons why is we have to develop this so we can put parts in. Like, for example, these notches on the outside are the same idea, only for notches, because we're going to be using magnets, and we want to know what size I have to make the holes so that the magnet fits correctly. There, that's too tight. It's actually splitting the plastic, and that I can get into, but it separates the plastic. And over here, the hole is too loose. Okay, so the purpose of this is to be able to identify, when I command a particular thing, how much do I really get? What tolerance do I really get? And how much clearance do I have to leave for real parts? Okay, so, and one of the things I found out about this is the holes are nice and loose at the top. Hold on. But as you get toward the bottom is a little bit smushed in. Not a big deal. A little file would take care of that. So now, again, this is the 0.3, I'm sorry, this is the 3 mil version. This is the 12 mil version. Okay, and you can see I hope you can see that on the bottom, you can see the better clearness of the resolution. Here, the media didn't even kind of make contact, so there's little gaps and holes in the media. Here, it's filled in nice. It's almost like glass. And on the top, the fill-in is a little bit better. The sides, they're about the same. This, you can actually see the laminations here, where you can't see the laminations here, but it looks like there's a little bit of ripple going in this direction. Hope you can see that. I don't know if I'm hitting the light right. I'll move it around to make sure it'll hit the light right for you. So let's look at the way the holes came out. And we'll start with this guy. And I'm just going to do one of the holes, the 0.75. So on the 0.75, and I also found, because I've already measured these before, that the holes aren't perfect, but they're not bad. I mean, they're not perfectly round. Okay, so that came out to 0.744 in one dimension. And it looks like 0.740 in another dimension. Get the magnet out of here. So for the 12 mil, it's 0.744 and 740. Okay, that is within the 12 mil tolerance that's specified. So, okay. And let's look at the 3/4 inch on this guy. The 3/4 inch is right next to the deepest hole, rectangular hole. This is 0.748. Let's try another. And 0.748 again. So this hole is a little bit more rounded. Okay. 0.748. Okay, that's definitely within the 3 mil tolerance that they specify. All right, so as far as what they specified, I'm happy because what they specify is basically where it comes out to be. Now the thicknesses of these should be a 1/2 inch. And this is 0.501 on the rough one. And 0.503 on the higher quality one. Or 0.502 if you go in band a little bit. So they're both within the tolerance specified. Now, I didn't specify, I wanted to see what a round part would be like. And I got this one. This little piece here was supposed to be a 1/2 inch plug inside the 0.76 inch hole. There should have been 5 thousandths around the hole, but obviously because this lower quality part can only get to within 12 thousandths, that the odds of this not getting fused in here was very nil. So, but I'm looking for a 1/2 inch here. And this is coming out to 0.747. So that's definitely within tolerance. 0.743, still within tolerance. So all in all, it did well. I'm happy with it. And again, this stuff is like really strong, considering that the inside is only filled in. Let me put the camera on pause and go cut this so you can see what the inside looks like. Okay, I just pulled this out on the bandsaw. It's kind of rough because the bandsaw kind of... But you can see that this isn't even filled up. This is considered a 20% fill. So of the interior parts, only 20% is actually filled in with material. So this is for a part that's mostly hollow. Okay, this is incredibly strong. And it's funny because when you actually look at the filament is very bendable. And it shows you that how you can make something very rigid just by how you rearrange the material. You can make something incredibly rigid. And so I'm very happy with the performance of this 3D printer. And so far, I've printed 3 things and they have come out exactly as I expected them to come out. There was no foul ups. There was no having to repeat things 10 times. I remember when I first got like a laser printer trying to get things to print right. You know, you'd have 10 or 15 test copies before you finally got all the settings right. This thing has been working out of the box perfectly. Everything has worked as advertised. So as far as I'm concerned, it's worth the money because it saved me a lot of time. And so we're good to go on this piece of equipment.